Hello, today my friend and I will conduct a topic about non-preemptive SJF. What is actually an SJF? SJF is the shortest job first, or it is referred as the shortest birth time, but it consists of two types, which is preemptive and non-preemptive. What I'm going to explain today is the non-preemptive SJF. Non-preemptive is a one schedule which does not consist any interruptions. It will directly execute the process. For this example of non-preemptive SJF, we will be using this table. This table consists of 5 processors from P1 until P5. In this table, it has the burst time, the arrival time, and the priority. Here is the ready state. The ready state will be organized according to the arrival time, the highest arrival time. For example, here P1 and P2 consist the same arrival time. So if the arrival time is the same, it will be referred to the highest burst time. 6 is the highest than 9. So in the ready state, P1 will be arrived first than the P2 because the P1 consists of the highest burst time.
To do the gun check, we need to do the ready state first. As we can see here, P3 arrived first because based on the table, P3 arrival time is 0. Obviously, 0 will be the first arrive. So we put here P3 arrived first. And the burst time is 7. The priority is 1. Second arrive is P1 and P2, but they have the same arrival time. When they have the same arrival time, we need to select the highest birth time. P1 has the highest birth time than P2. So we put here P1, birth time is 6, priority is 3. Following P2, birth time is 9, priority is 4. Then P4, birth time is 3, priority is 1. The last one is P5. Birth time is 4, priority is 2. After then do the ready state, we need to do the gun check. The gun check will start from 0, and based on the table, P3 arrival time is 0, so we put here P3, and the end time of P3 is 7, based on the burst time P3. Next, we don't need the table, so put it aside. We just focus to ready state to do the gun check. And we have to choose the highest burst time. So P4 has the highest burst time among the others. So we put here P4, and the end time of P4, we take the end time of P3 plus the burst time of P4. So 7 plus 3 is 10. Next, the highest birth time is P5. So we put here P5, the end time P5, we take P4 end time plus the birth time P5, and 10 plus 4 is 14. Following to the next is P1. The end time P1, we take end time P5 plus birth time P1, 6, so 20. The end one is P2, 20 plus P2 birth time is 9, 9 and 29. After what I have explained just now, I'm going to explain about the waiting time. In the waiting time, you don't have to arrange the process according to the arrival time. It does not matter what process comes first. Okay, now let's proceed with it. For the P1, we are taking the visit time of the P1 in the Gantt chart, which is 14, and we are going to minus it with the arrival time of P1, which is 2. So 14 minus 2 is 12. Same goes to P2. We are taking the visit time of P2, which is 20, and minus to the arrival time of P2, which is 2. So 20 minus 2 is 18. Okay, ta-da! I have done the calculation for you, which is P3, the answer is 0. And P4, the answer of is 2. And P5, the answer is 4. The final step is to calculate the average waiting time. Here, in the average waiting time, we are going to add up the answer from the waiting time. Here, all of the answer, and divide it with the total process, which is 5 process: P1, P2, P3, P4, and P5. So 12 plus 18 plus 0 plus 2 plus 4 divide by 5 process, and the answer from the calculation is 7.2.